application. Say for example, you are dealing with a 2.0 application, how you go ahead and crawl the entire application as such. That is very interesting crawling and enumeration for the Web 2.0 application, which essentially dynamic page creation through JavaScript, and you have a DOM event management from the application layer and DOM having a clear context. So if you try to crawl these applications using your protocol driver, you open a socket, you send a GET request, you get a page, you have a href, you pass all href and keep on bundling this request, and then you make a complete crawling on the site, which will not work over here, because to crawl the site, what you need is two important things. One, you need a JavaScript execution capability, and even you have a JavaScript execution capability, you need a context of that particular DOM. So if you have both of them together, then you can fire the right event to crawl the application. So over here, for example, if you go ahead, and this is a typical dynamic site for a sample. So what you have is, when you load this site, it will load 4 hyperlinks on the site. Now all these hyperlinks are not part of your HTML page, it is coming as your AJAX call. So if you look at the source of the page over here, the source of page is like a 4-line of scripts which is getting loaded in your browser. There is no href you can see in this HTML page. So you are like, if you start crawling this application, you are like at the first page your crawler will stop, because there is no href, there is no form button, there is nothing is on it essentially. It's all in the JavaScript which get executed dynamically once it gets loaded on your DOM. So then you start crawling this application once you start clicking all these different buttons over here, say news or whatever button you click, everything is going over AJAX call. So essentially what we are looking at over here is like a one-page application. It's like nothing else on this particular page. It's like a one-page application. So say for example, interestingly, if you visit msnsearch.com, msnsearch.com is like a one-page application where there is a backend web services running with 132 functions. So like what you crawl, like you go make a request to a slash and your crawler will end, because there is nothing else in the application. So say for example, you start crawling these kind of application with the Paros. This Paros is like one of the scanner which you are using in crawling, and over here you start a crawling and it will stop very soon that nothing is found. There is no link. When you reload this particular page in your browser, you can see so many links. You can click events, you can do a lot of stuff. Over here you pretty much don't see anything. So your crawling is finished over here. Now what you need to do is, over here what I do is I do a whatever. So whatever is a type of a driver which you load from the Ruby script. So you write your Ruby script, tell your IE to load this page, and then dynamically click with various different links. So if you are doing that, then you are actually doing something which a human is doing. So you can write the script, run against your Web 2.0 application, go home and sleep, and in the morning when you come, you have the complete traffic with you. You run the pattern on the traffic and capture all the links and the resources from the site. So over here, what I'm doing is I'm just saying IE to go to my target application, and then slip for a 1 and start clicking all these different events, or all these different events or links which I find on the site. So very quickly I can crawl the application. As you can see, everything is happening automatically over here, and then I'm collecting all the hrefs through the script. So all these hrefs is getting collected, and now I have a full profile of this particular application, that this is the application running with this web server, running with this application framework, it is running with this JavaScript library, it is using JSON and XML on these particular resources, and blah 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 blah. So you have a full list with you. So this is one approach by you can crawl the application. And second is you can do in-browsing crawling. There are various different plugins out there. For example, Chicken Food is one of the plugin which you plug into your Firefox and write a little script in a JavaScript and tell your plugin that I am loading whatever is loaded in my current DOM. You parse that, collect any link which is starting with a JavaScript, so you know that that href is pointing to a JavaScript in your DOM. And then if it is pointing or starting with a JavaScript, you click that particular link. Very simple, like a human or like a way we are thinking. So then you can see all these different events are already fired. You it made all the 5 links which is clicked by itself, and then you have a traffic over here which you can analyze and determine what's going on. So this is the way essentially what you are doing is identifying your different attack vectors. Now we move to attack vectors. Once you are done with that, now we are looking at the top 10 attack vectors. First is Ajax-driven cross-site scripting, second is a JavaScript, and so on. So first is Ajax-driven cross-site scripting. What is different in Ajax-driven cross-site scripting? First is Ajax call get a stream. So when you make an Ajax call, you get a stream back from your server. Now, when your already DOM is preloaded and new stream coming from the server, what you need to do is this stream has to be injected into your current DOM. So there is some kind of a call which will take this new stream and inject into a current memory space. So it uses either a call called eval. So whatever is coming, it's do a eval. It's like doing a command execution on your browser's DOM and through a JavaScript. Or you need to do a rewriting, whether you do a document.write or you change the inner HTML or such. So one of the fundamental thing over here is that the stream which is coming to your browser is coming from the untrusted source if you are running in the mashup application, and cross-domain calls are very common So you have a cross-domain calls are one of the important ingredient of your Web 2.0 application, and to bypass a cross-domain or a same origin policy in your browser, developers have done three ways. One is it will talk with, those calls will go through the proxy. So say for example, I am on xyz.com, I can't go to the google.com. So what I will do is on the xyz.com, I will create a proxy and my application will call the proxy and tell the proxy that go to the google.com and this is a gentleman's username and password, go and grab their email and tunnel it back to me. So that's a number one proxy. Then there is something called callback implementation, which is if your APIs are supporting that, then you can wrap around your callback function and make sure that when stream comes back, you process into that particular function. And then if you are using a Flash application, then you have a cross-domain XML where you can code it up and say that if my application is trying to call these three domains, just count it as a trusted and let the traffic go. So this is how your cross-domain calls are going to get bypassed. Now, how a scenario of injection on the 2.0 application is going to happen is an attacker will write something on the blog. That blog will get converted into a kind of a JSON feed, and that will go and waiting for on the proxy. So when your web client or you get connected through the application and looking for that particular blog values, that you are not going to that blog, but the stream which is written is coming to you. So then that JSON field will tunnel through a proxy, will go to the web server, come to the web client, and then it will process your JSON, it will do the eval. As soon as it will do the eval, if your stream is not validated, if it has a malicious code inside, then that is going to cause a cross-site scripting on your site, on your browser. Now this is like a third kind of cross-site scripting, which is a document object model or a DOM-based cross-site scripting. And this can be very lethal. This cross-site scripting with RAA, it's possible if you are using a rich data application, then it's going to go through that. And these are the functions by which these can happen, document.write, or it can go over a JSON, or it can go over a JS array or such. Just the same kind of a mechanism can be leveraged in terms of a second attack vector, which is a JavaScript injection and mashup. So mashup applications are combinations of different APIs, and you have a source of information coming from untrusted, and when these callbacks are getting executed in your browser will cause a cross-site scripting. So say for example over here I have where it is. Over here I have this application running where there is a mashup. So this is a typical mashup of your Google and eBay. So like on this particular site, whatever DVDs are posted on by someone on this particular zip, show me that. So then these are some of the products are posted. Now you are running with the JavaScript where it is communicating with these two different domains, bringing everything onto it and running on your site. Now you are looking for these guys' profile. You go there and click this guy, and you can see over here what he has posted and who he is and such. Now if you start analyzing the traffic over here, as soon as you click this, you have you have, when you click this, it is sending you a XML stream, his first name, last name and a number, and that is going to get executed in your browser. So essentially over here, when you say, for example, I click this guy over here and do a view page source over here, this is how the XHR call will go out, grab that information, and over here you can see it is doing a document.write calls over here. So this is the way how it is going to execute the new incoming stream, which is coming from the untrusted source. Now, if that particular profile, if I click over here, it is a cross-site scripting 2.0. What have happened is this guy has injected a malicious JavaScript in his last name. Now your application is going out through the proxy, grabbing the information from completely untrusted source, taking that and making the eval and document.write on your domain. So now with this, whoever is visiting these guys' profile is going to get XSS. So this is like a different kind of a 2.0 kind of XSS, which is a DOM driven, number one, and number two, it is coming from the untrusted sources. So this is A2. Number three is like SQL injection over 2.0 type. This is another interesting vector. In a traditional SQL injection, what you have over here is a get and post, where you have inject a value over here and you get the response back, and from which you identify whether it is running with the bug or not. Now 2.0 traffic would be going over a JSON or XML. So say for example over here, I have a typical, say, this is my typical 1.0 resource, where you have a page and you have ID equal to 1, where you put ID and you get a product information out. So if you put 2, you get a second information and such. And as soon as you see this, the traditionally way you put a single quote and try to see how application is holding up, and you get SQL error and blah blah blah, and you have now know that this is a 1 or SQL injection point you have found. But if it is a 2.0 application, this is your application. Your catalog would look like this. There is no ID over here on a top, and if you click this link, your things are dynamically changing over here. If you want to see this product, it is changing over here and so forth. So now you don't have that ID parameter over here or a name value pair where you can change. So now if say for example you do a traffic analysis over here with the paros, say for example, and try to see what's going back and forth. Do a new session over here and trap the request. As soon as I click this guy, this is the traffic which is going. This is little JSON traffic which is going, and you have a product 2 information going over here. So say instead of a 2 you put A and continue. You get the response back, and here is your response. You can see SQL exception error coming over here, but in a browser you don't see anything. So it's not like the typical 500O, or it's not typical 200 which you are looking at. So you need to do this dissecting of the information and try to identify where the errors are coming. Now this is an error coming from the framework which is running the JSON objects. So now you have the SQL injection point found. So now you go ahead and click this guy and identify this request, and over here you already have a trap place. So you encapsulate with this, say, double quotes, put 1 or 1 equal to 1 and continue, and in a response for this second product you can see the whole product table coming out. Instead of getting a one product, now you are starting to see all the products, and your SQL injection vectors will start working on JSON pipe. So this is kind of a new kind of a SQL injection. It is not a new kind of, but like a payload is the same, but your delivery mechanism is different, which you need to analyze. 3 is a cross-site request forgery. Generic CSRF with a get and post. You have IMG script and iframe tags through which you implement your that. Now IMG script and various other tags don't have to follow same origin policy. So what you have is a cross-site request forgery for Web 2.0 traffic. So say for example you are using XML traffic for marshalling your request back and forth. on